Introductions and Prologue to Uller Uprising. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Ralph Snelson. Uller Uprising by Henry Beam Piper. Introduction by John F. Carr. With the publication of this novel, Uller Uprising, all of H. Beam Piper's previously published science fiction is now available in Ace editions. Uller Uprising was first published in 1952 in a Twain science fiction triplet, a hardbound collection of 3 thematically connected novels. The other 2 were Judith Merrill's Daughters of Earth and Fletcher Pratt's The Long View. A year later, it appeared in the February and March issues of Space Science Fiction, edited by Lester Del Rey. The magazine version, which was abridged by about a third, was believed by many bibliographers to be the only version, and as a novella it was too short for book publication. The Twain version had a small print run, and is so scarce that few people have seen it. Those bibliographers who knew of its existence assumed that both versions of Uller were the same. It was through a telephone conversation with Charles N. Brown, publisher of Locus and correspondent with Piper, that I learned about the Twain edition and its greater length. Brown allowed me to photocopy his original, for which we owe him a debt of thanks, because the Twain version is not only novel length, but far better than the shorter one that appeared in Space Science Fiction. Probably the most surprising and interesting thing about the Twain edition is the essay that forms the introduction to that volume and is reprinted here. The essay is by Dr. John D. Clark, an eminent scientist of the 40s and 50s, and one of the discoverers of sulfa, the first miracle drug. It describes in great detail the planetary system of the star Beta Hydrae, and gives the names of those planets, Uller and Niflheim. A publisher's note states that Clark's essay was written first, and given to the contributors as background material for a novel they would then write. The fans of H. Beam Piper seem to owe a great debt to Dr. Clark. Uller Uprising became the foundation of Piper's monumental Terro-Human future history, the first story where we encounter the Terran Federation. In it we learn about Odin, the planet that will one day be the capital of the first galactic empire, and humble Niflheim, which in more decadent times will become a common expletive, a word meaning hell. This is also where Piper introduced and explained the atomic era dating system, AE. Uller Uprising is set in the early years of the Terran Federation's expansion and exploration, an epoch of great vitality. In The Edge of the Knife, Piper compares this time of discovery to the Spanish conquest of the Americas. This feeling of vigor and unlimited possibilities runs through all the early Federation stories, Uller Uprising, Omnilingual, Nonsense, When in the Course, and to a lesser degree in the late Federation novels Little Fuzzy, Fuzzy Sapiens, and Fuzzies and Other People. See Federation by H. Beam Piper for a good overview of this period. In these stories we see Terro-Humans at their best and at their worst, individual heroism and bravery in the face of grave danger in Uller Uprising, Federation law and justice in Little Fuzzy and its sequels, and in Omnilingual and Nonsense, the spirit of science and rational inquiry. Yet we also see colonial exploitation and subjugation in Uller Uprising and Umful in the Sky, the greed and corruption of chartered land companies in Little Fuzzy, and political corruption in 4-Day Planet. These stories are about a living Terro-Human culture, not a utopia. It was Piper's attention to historical realism and his use of actual historical models that have helped his work to pass the test of time and have led to his becoming the favorite of a new generation of readers more than 25 years after his death. Uller Uprising is the story of a confrontation between a human overlord and alien servants, with an ironic twist at the end. Like most of Piper's best work, Uller Uprising is modeled after an actual event in human history. In this case, the Sepoy Mutiny, a Bengal uprising in British-held India, brought about when rumors were spread to native soldiers that cartridges being issued by the British were coated with animal fat. The rebellion quickly spread throughout India and led to the massacre of the British colony at Cawnpore. Piper's novel is not a mere retelling of the Indian Mutiny, but rather an analysis of an historical event applied to a similar situation in the far future. Like many philosophers and social theorists before him, Piper attempted to chart the progress of humankind. Unlike most, however, he did not envision or try to create a system of ethics that would end all of humanity's problems. The best he could offer was his model of the self-reliant man, the man who actually knows what has to be done and how to do it, and he's going to go right ahead and do it, without holding a dozen conferences and round-table discussions, and giving everybody a fair and equal chance to foul things up for him. Piper brought his own ideas and judgments about society and history into all of his work, but they appear most clearly in his Terro-Human Future History. While not everyone will agree with Piper's theories, they give his work a bite that most popular fiction lacks. One cannot read Piper complacently, and one can often find a wry insight sandwiched in between the blood and thunder. Other future histories may span more centuries, or better illuminate the highlights of several decades, but until a rival is created with more historical depth and attention to detail, H. Beam Piper's Terro-Human Future History will stand as the Bayeux Tapestry of science fiction histories. In many ways, certainly during his lifetime, Piper was the most underrated of the John W. Campbell's astounding writers. He was probably also the most Campbellian. His self-reliant man is almost a mirror image of Campbell's Citizen. Piper died a bitter man, a failure in his own mind. Shortly before his death, he believed he could no longer earn a living as a writer without charity from his friends or the state. Now he's the cornerstone of Ace Books. Had he lived long enough to finish another half-dozen books, he would have been among the science fiction greats of the '60s. But maybe he does know, after all. Jerry Pournelle, who was very much influenced by Piper, and in many ways considers himself Beam's spiritual descendant, and incidentally was John W. Campbell's last major discovery, has said that sometimes when he's gotten down a particularly good line, he can hear the old man chuckle and whisper, "Attaboy." End of introduction number 1. Introduction by Dr. John D. Clark. The Silicon World. 1. The star and its most important planet. The planet is named Uller. It seems that when interstellar travel was developed, the names of Greek gods had been used up, so those of Norse gods were used. It is the second planet of the star Beta Hydrae, right angles 0:23, declension -77:32, G0, solar type star, of approximately the same size as Sol, distance from Earth 21 light years. Uller revolves around it in a nearly circular orbit, at a distance of 100 million miles, making it a little colder than Earth. A year is of the approximate length of that on Earth. A day lasts 26 hours. The axis of Uller is in the same plane as the orbit, so that at a certain time of the year the North Pole is pointed directly at the sun, while at the opposite end of the orbit it points directly away. The result is highly exaggerated seasons. At the poles the temperature runs from 120 degrees Celsius to a low of -80 degrees Celsius. At the equator it remains not far from 10 degrees Celsius all year round. Strong winds blow during the summer and winter, from the hot to the cold pole. few winds during the spring and fall. The appearance of the poles varies during the year from baked deserts to glaciers covered with solid CO2. Free water exists in the equatorial regions all year round. 2. Solar movement as seen from Uller. As seen from the North Pole, no sun is visible on January 1. On April 1, it bisects the horizon all day, swinging completely around. April 1 to July 1, it continues swinging around, gradually rising in the sky, the spiral converging to its center at the zenith, which it reaches July 1. From July 1 to October 1, the spiral starts again, spreading out from the center until on October 1 it bisects the horizon again. On October 1, night arrives to stay until April 1. At the equator, the sun is visible bisecting the southern horizon for all 26 hours of the day on January 1. From January 1 to April 1, the sun starts to dip below the horizon at night, to rise higher above it during the day. During all this time, it rises and sets at the same hours, but rises in the southeast and sets in the southwest. At noon it is higher each day in the southern sky until April 1, when it rises due east, passes through the zenith, and sets due west. From April 1 to July 1, its noon position drops down to the north until on July 1 it is visible all day, bisected by the northern horizon. 3. Chemistry and geology of Uller. Calcium and chlorine are rarer than on Earth. Sodium is somewhat commoner. As a result of the shortage of calcium, there is a higher ratio of silicates to carbonates than exists on Earth. The water is slightly alkaline and resembles a very dilute solution of sodium silicate, water glass. It would have a pH of 8.5 and taste slightly soapy. Also, when it dries out, it leaves a sticky and then a glassy, crackly film. Rocks look fairly Earth-like, but the absence or scarcity of anything like limestone is noticeable. Practically all the sedimentary rocks are of the sandstone type. All rivers are seasonal, running from the polar regions to the central seas in the spring only, or until the polar cap is completely dried out. 4. Animal life. As on Earth, life arose in the primitive waters, and with a carbon base, but because of the abundance of silicone, there was a strong tendency for the microscopic organisms to develop silicate exoskeletons, like diatoms. The present invertebrate animal life of the planet is of this type, and is confined to the equatorial seas. They run from amoeba-like objects to things like crayfish, with silicate skeletons. Later, some species of them started taking silicone into their soft tissues, and eventually their carbon chain compounds were converted to silicone-type chains, from diagram 1 to diagram 2, with organic radicals on the side links. These organisms were a transitional type, with silicone tissues and water body fluids, resembling the earthly amphibians, and are now practically extinct. There are a few species, something like segmented worms, still to be seen in the backwaters of the central seas. A further development occurred when the silicone chain animals began to get short chain silicones into their circulatory systems, held in solution by OH or NH2 groups on the ends and branches of the chains. The proportion of these compounds gradually increased until the water was a minor and then a missing constituent. The larger mobile species were then practically anhydrous. Their blood consists of short chain silicones with quartz reinforcing for the soft parts, and their armor, teeth, and etc. of pure amorphous quartz, opal. Most of these parts are of the milky variety, variously tinted with metallic impurities, as are the varieties of sapphires. These pure silicone animals, due to their practical indestructibility, annihilated all but the smaller of the carbon animals, and drove the compromised types into odd corners as relics. They developed into a fish-like animal with a very large swim bladder to compensate for the rather higher density of the silicone tissues, and from these fish the land animals developed. Due to their high density and resulting high weight, they tend to be low on the ground, rather reptilian in look. 3 pairs of legs are usual in order to distribute the heavy load. There is no sharp dividing line between the quartz armor and the silicone tissue. One merges into the other. The dominant, pure silicone animals only could become mobile and venture far from the temperate equatorial regions of Uller, since they neither froze nor stiffened with cold, nor became incapacitated by heat. Note that all animal life is cold-blooded, with a negligible difference between body and ambient temperatures. Since the animals are silicones, they don't get sluggish like cold snakes. 5. Plant life. The plants are of the carbon metabolism, silicate shell type, like the primitive animals. They spread out from the equator as far as they could go before the baking polar summers killed them. They have normal seasonal growth in the temperate zones and remain dormant and frozen in the winter. At the poles there is no vegetation, not because of the cold winter, but because of the hot summer. The winter winds frequently blow over dead trees and roll them as far as the equatorial seas. Other dead vegetation, because of the highly silicious water, always gets petrified unless it is eaten first. What with the quartz speckled hides of the living vegetation and the solid quartz of the dead, a forest is spectacular. The silicone animals live on the plants. They chew them up, dehydrate them, and convert their silicious outer bark and carbonaceous interiors into silicones for themselves. When silicone tissue is metabolized, the carbon and hydrogen go to CO2 and H2O, which are breathed out, while the silicone goes into SiO2, which is deposited as more teeth and armor. Compare the terrestrial octopus, which makes armor plating out of calcium urate instead of excreting urea or uric acid. The animals can, of course, eat each other too, or make a meal of the small carbonaceous animals of the equatorial seas. Further note that the animals cannot digest plants when they are cold. They can eat them and store them, but the disposal of the solid water and CO2 is too difficult a problem. When they warm up, the water in the plants melts and can be disposed of, and things are simpler. Part 2. The Fluorine Planet. 1. The Star and Planet. The planet named Niflheim is the 4th planet of Nu Puppis. Right angle 6:36, declension -43:09, B8 type star, blue-white and hot, 148 light years distant from Earth, which will require a speed in excess of light to reach it. Niflheim is 462 million miles from its primary, a little less than the distance of Jupiter from our sun. It thus does not receive too great a total amount of energy, but what it does receive is of high potential, a large fraction of it being in the ultraviolet and higher frequencies. Watch out for really super special sunburn, and so on unwarned personnel. The gravity of Niflheim is approximately 1 g, the atmospheric pressure approximately 1 atmosphere, and the average ambient temperature about -60 degrees Celsius, -76 degrees Fahrenheit. 2. Atmosphere. The oxidizer in the atmosphere is free fluorine, F2, in a rather low concentration, about 4 or 5%. With it appears a mad collection of gases. There are a few inert diluents, such as N2, nitrogen, argon, helium, neon, and so on, but the major fraction consists of CF4, carbon tetrafluoride, BF3, boron trifluoride, SiF4, silicon tetrafluoride, PF5, phosphorus pentafluoride, SF6, sulfur hexafluoride, and probably others. In other words, the fluorides of all the non-metals that can form fluorides. The phosphorus pentafluoride rains out when the weather gets cold. There is also free oxygen, but no chlorine. That would be liquid, except in very hot weather. It sometimes appears combined with fluorine in chlorine trifluoride. The atmosphere has a slight yellowish tinge. 3. Soil and geology. Above the metallic core of the planet, the lithosphere consists exclusively of fluorides of the metals. There are no oxides, sulfides, silicates, or chlorides. There are small deposits of such things as bromine trifluoride, but these have no great importance. Since fluorides are weak mechanically, the terrain is flattish. Nothing tough like granite to build mountains out of. Since the fluoride ion is colorless, the color of the soil depends upon the predominant metal in the region. As most of the light metals also have colorless ions, the colored rocks are rather rare. 4. The waters under the earth. They consist of liquid hydrofluoric acid, HF. It melts at -83 degrees Celsius and boils at 19.4 degrees Celsius. In it are dissolved varying quantities of metallic and non-metallic fluorides, such as boron trifluoride, sodium fluoride, etc. When the oceans and lakes freeze, they do so from the bottom up, so there is no layer of ice over free liquid. 5. Plants and plant metabolism. The plants function by photosynthesis, taking HF as water from the soil, and carbon tetrafluoride as the equivalent of carbon dioxide from the air, to produce chain compounds such as this diagram, and at the same time liberating free fluorine. This reaction could only take place on a planet receiving lots of ultraviolet, because so much energy is needed to break up carbon tetrafluoride and hydrofluoric acid. The plant catalyst, doubling for the magnesium in chlorophyll, is nickel. The plants are colored in various ways. They get their metals from the soil. 6. Animals and animal metabolism. Animals depend upon two main reactions for their energy and for the construction of their harder tissues. The soft tissues are about the same as the plant molecules, but the hard tissues are produced by the reaction shown in these two diagrams, resulting in a Teflon boned and shelled organism. He's going to be tough to do much with. Diatoms leave strata of powdered Teflon. The main energy reaction is shown in this diagram. The blood catalyst metal is titanium, which results in colorless arterial blood and violet venous, as the titanium flips back and forth between tri and tetravalent states. 7. Effect on intruding items. Water decomposes into oxygen and hydrofluoric acid. All organic matter, earth type, converts into oxygen, carbon tetrafluoride, hydrofluoric acid, and etc., with more or less speed. A rubber gas mask lasts about an hour. Glass first frosts and then disappears. Plastics act like rubber, only a little slower. The heavy metals, iron, nickel, copper, monel, and etc., stand up well, forming an insoluble coat of fluorides at first, and then doing nothing else. 8. Why go there? Large natural crystals of fluorides, such as calcium difluoride, titanium tetrafluoride, zirconium tetrafluoride, are extremely useful in optical instruments of various forms. Uranium appears as uranium hexafluoride, all ready for the diffusion process. Compounds of such nonmetals as boron are obtainable from the atmosphere in high purity with very little trouble. All metallurgy must be electrical. There are considerable deposits of beryllium, and they occur in high concentration in its ores. End of introduction number 2. Uller Uprising by Henry Beam Piper. Prologue. On Satan's Footstool. The big armor tender vibrated gently and not unpleasantly as the contragravity field alternated on and off, occasionally varying its normal rate of 500 to the second when some thermal updraft lifted the vehicle and the automatic radar altimeter control acted to alter the frequency and lower it again. Sometimes it rocked slightly like a boat on the water, and in the big screen which served in lieu of a window at the front of the control cabin, the dingy yellow landscape would seem to tilt a little. If unshielded human eyes could have endured the rays of Nu Puppis, Niflheim's primary, the whole scene would have appeared a vivid St. Patrick's Day green, the effect of the blue predominant light on the yellow atmosphere. The outside visor pickup, however, was fitted with filters which blocked out the gamma rays and X-rays and most of the ultraviolet rays, and added the longer light waves of red and orange, which were absent, so that things looked much as they would have under the light of a G0 type star like Sol. The air was faintly yellow, the sky was yellow with a greenish cast, and the clouds were green-gray. 1,000 feet below, the local equivalent of a forest grew, the trees topped with huge ragged leaves, looking like 100-foot stalks of celery. There would be animal life down there too, little round things 4 inches across, like 8-legged crabs, gnawing at the vegetation, and bigger things 2 feet long, with articulated shell armor, and 16 legs which fed on the smaller herbivores. Beyond, in the middle ground, was open grassland, if one could so call a mat of worm-like colorless or pastel-tinted sprouts, and a river meandered through it. On the skyline, 50 miles away, was a range of low dunes and hills, none more than 1,000 feet high. No human had ever set foot on the surface or breathed the air of Niflheim. To have done so would have been instant death. The air was a mixture of free fluorine and fluoride gases. The soil was metallic fluorides, damp with acid rains, and the river was pure hydrofluoric acid. Even the ordinary spacesuit would have been no protection. The glass and rubber and plastic would have disintegrated in a matter of minutes. People came to Niflheim and worked the mines and uranium refineries and chemical plants, but they did so inside power-driven and contragravity-lifted armor, and they lived on artificial satellites 2,000 miles off-planet. This vehicle, for instance, was built and protected as no spaceship ever had to be, completely insulated and entered only through a triple airlock, an outer lock which would be evacuated outward after it was closed, a middle lock kept evacuated at all times, and an inner lock evacuated into the interior of the vehicle before the middle lock could be opened. Niflheim was worse than airless, much worse. The chief engineer sat at his controls, making the minor lateral adjustments in the vehicle's position which were not possible to the automatic controls. One of the radio men was receiving from the orbital base. The other was saying over and over in an exasperatedly patient voice, "Dr. Murillo! Dr. Murillo! Please come in, Dr. Murillo!" At his own panel of instruments, a small man with grizzled black hair around a bald crown and a grizzled beard chewed nervously at the stump of a dead cigar and listened intently to what was, or for what wasn't, coming in to his headset receiver. A couple of assistants checked dials and refreshed their memories from notebooks and peered anxiously into the big screen. A large, plump-faced young man in soiled khaki shirt and shorts with extremely hairy legs was doodling on his notepad and eating candy out of a bag, and a black-haired girl in a suit of coveralls 3 sizes too big for her, and apparently not much of anything else, lounged with one knee hooked over her chair arm, staring into the screen at the distant horizon. "Dr. Murillo! Dr. Mur—" The radio man broke off in mid-syllable and listened for a moment. "I hear you, doctor. Go ahead." Then a moment later, "What's your position now, doctor?" "I can see them," the girl said, lifting a hand in front of her. "At 2 o'clock, about one of my hand's breadths above the horizon." The man with the grizzled beard put his face into the fur around the eyepiece of the telescopic visor and twisted a dial. "You have good eyes, Miss Quinton," he complimented. "Only 4 personal armors. Ahmed, ask him where the 5th is." "We only see 4 of your personal armors," the radio man said. "Who's missing, and why?" He waited for a moment, then lowered the hand phone and turned. "The 5th one's inside the handling machine. One of the Ullerans, Gorkrink." The larger of the specks that had appeared on the horizon resolved itself into a handling machine, a thing like an oversized contragravity tank with a bulldozer blade, a stubby derrick boom instead of a gun, and jointed, claw-tipped arms to the sides. The smaller dots grew into personal armor, egg-shaped things that sprouted arms and grab hooks and pushers in all directions. The man with the grizzled beard began talking rapidly into his hand phone, then hung it up. There was a series of bumps, and the armor tender, weightless on contragravity, shook as the handling machine came aboard. "You ever see any nuclear bombing, Miss Quinton?" the young man with the hairy legs asked, offering her his candy bag. "Only by telecast, back Sol side," she replied, helping herself. "Test shots at the Federation Navy proving ground on Mars. I never even heard of nuclear bombs being used for mining till I came here, though." "Well, if this turns out as well as the other job 3 months ago, it'll be something to see," he promised. "These volcanoes have been dormant for, oh, maybe as long as 1,000 years. There ought to be a pretty good head of gas down there, and the magma'll be thick, viscous stuff like basalt on Terra. Of course, this won't be anything like basalt in composition. It'll be intensely compressed metallic fluorides with a very high metal content. The volcanoes we shot 3 months ago yielded a fine flow of lava with all sorts of metals: nickel, beryllium, vanadium, chromium, indium, as well as copper and iron." "What sort of gas were you speaking about?" she asked. "Hydrogen. That's what's going to make the fireworks. It combines explosively with fluorine. The hydrogen fluorine combination is what passes for combustion here. The result is hydrofluoric acid, the local equivalent of water. See, the metallic core of this planet is covered much less thickly than that of Terra, with fluoride rock, fluorspar, and that sort of thing. There's nothing like granite here, for instance. That's why those big dunes out there are the best Niflheim has in the way of mountains. The subsurface hydrogen is produced when the acid filters down through the rock, combines with pure metals underneath." "Dr. Murillo's inside now," the radio man said. "Just came out of the inner airlock. He'll be up as soon as he gets out of his pressure suit." "As soon as he gets here, I'll touch it off," the bearded man said. "Everything set, de Jong?" "Everything ready, Dr. Gomes," one of his assistants assured him. The door at the rear of the control cabin opened, and Juan Murillo, the seismologist, entered, followed by an assistant. Murillo was a big man, copper skinned, barrel-chested. He looked like a 3rd or 4th generation Martian, of Andes Indian ancestry. He came forward and stood behind Gomez's chair, looking down at the instruments. His assistant stopped at the door. This assistant was not human. He was a biped, vaguely humanoid, but he had 4 arms and a face like a lizard's, and except for some equipment on a belt, he was entirely naked. He spoke rapidly to Murillo in a squeaking jabber. Murillo turned. "Yes, if you wish, Gorkrink," he said in the English-Spanish Afrikaans Portuguese mixture that was 6th century AE lingua terra. Then he turned back to Gomes as the Ulleran sat down in a chair by the door. "Well, she's all yours, Lourenço. Shoot the works." Gomes stabbed the radio detonator button in front of him. A voice came out of the PA speaker overhead. "In 60 seconds, the bombs will be detonated." 30 seconds. 15 seconds. 10 seconds. 5 seconds. 4 seconds. 3 seconds. 2 seconds. 1 second. Out on the rolling skyline, 50 miles away, a lance-like ray of blue-white light shot up into the gathering dusk, a clump of 5 rays really, from 5 deep shafts in an irregular pentagon half a mile across, blended into one by the distance. An instant later there was a blinding flash like sheet lightning, and a huge ball of varicolored fire belched upward, leaving a series of smoke rings to float more slowly after it. That fireball flattened, then spread to form the mushroom head of a column of incandescent gas that mounted to overtake it, engorging the smoke rings as it rose, twisting, writhing, changing shape, turning to dark smoke in one moment and belching flame and crackling with lightning the next. The armor tender began to pitch and roll. It was all the engineer and one of the assistants could do together to keep it level. In about half an hour, the large young man told the girl, the real fireworks should be starting. What's coming up now is just small debris from the nuclear blast. When the shock waves get down far enough to crack things open, the gas'll come up, and then steam and ash, and then the magma. This one ought to be twice as good as the one we shot 3 months ago. It ought to be every bit as good as Krakatoa on Terra in '59 pre-atomic. Well, even this much was worth staying over for, the girl said, watching the screen. "You going on to Uller on the city of Canberra?" Lourenço Gomes asked. "I wish I were. I have to stay over and make another shot in a month or so, and I've had about all of Niflheim I can take now. The sooner I get onto a planet where they don't ration the air, the better I'll like it." "Well, what do you know?" the large young man with the hairy legs mock marveled. "He doesn't like our nice planet." "Nice planet," Gomes muttered something. "They call Terra God's footstool. Well, I'll give you one guess who uses this thing to prop his cloven hoofs on." "When are you going to Terra?" the girl asked him. "Terra? I don't know. A year, 2 years. But I'm going to Uller on the next ship, the City of Pretoria, if we get the next blast off in time. They want me to design some improvements on a couple of power reactors, so I'll probably see you when I get there." "Here she comes!" the chief engineer called. "Watch the base of the column." The pillar of fiery smoke and dust, still boiling up from where the bombs had gone off far underground, was being violently agitated at the bottom. A series of new flashes broke out, lifting and spreading the incandescent radioactive gases, and then a great gush of flame rose. A column of pure hydrogen must have rushed up into the vacuum created by the explosion. The next blast of flame, in a lateral sheet, came at nearly 10,000 feet above the ground, and great rags of fire, changing from red to violet and back through the spectrum to red again, went soaring away to dissipate in the upper atmosphere. Then geysers of hot ash and molten rock spouted upward. Some of the white-hot debris landed almost at the acid river, halfway to the armor tender. "We've started a first-class earthquake, too," the Hispano-Indian Martian Murillo said, looking at the instruments. "About 6 big cracks opening in the rock structure. You know, when this quiets down and cools off, we'll have more ore on the surface than we can handle in 10 years, and more than we could have mined by ordinary means in 50. About 4 miles from the original blast, another eruption began with a terrific gas explosion. "Well, that finishes our work," the large young man said, going to a kit bag in the corner of the cabin and getting out a bottle. "Get some of those plastic cups over there, somebody. This one calls for a drink." "That's right," Gomes said. "You do something once, it may be an accident. You repeat the performance and it's a success." He began pushing papers aside on his desk, and the girl in the 2 ample coveralls brought drinking cups. The Ulleran in the background rose quickly and squeaked apologetically. Murillo nodded. "Yes, of course, Gorkrink. No need for you to stay here." The Ulleran went out, closing the door behind him. "That taboo against Ullerans and Terrans watching each other eat and drink," Murillo said. "What is that, part of their religion?" "No, it's their version of modesty," the girl replied. "Like some of our sex inhibitions, which they can't even begin to understand." "But you were speaking to him in Lingua Terra. I didn't know any of them understood it." "Gorkrink does," Murillo said, uncorking the bottle and pouring into the plastic cups. "None of them speak it, of course, because of the structure of their vocal organs, any more than we can speak their languages without artificial aids. but I can talk to him in Lingua Terra without having to put one of those damn gags in my mouth, and he can pass my instructions on to the others. He's been a big help. I'll be sorry to lose him." "Lose him?" "Yes, his year's up. He's going back to Uller on the Canberra. You know it's impossible to keep some trace of fluorine from the air in the handling machines, or even out on the orbiters, and it plays the devil with their lungs. He wanted to stay on another 3 months, to help with the next shot, but the medics wouldn't hear of it. He's from Keegark, wherever on Uller that is. Claims to be a prince or something. I know all the other geeks kowtow to him. But he's a damn good worker, very smart, picks things up the first time you tell him. I'll recommend him unqualifiedly for any kind of work with contragravity or mechanized equipment." They all had drinks now, except the chief engineer, who wanted a rain check on his. "Well, here's to us," Murillo said, "the first A-bomb miners in history." End of Introductions and Prologue.